If you click this video away, then please tell me what the reason was so that I can improve. Otherwise, hi and welcome. I'm trying to learn climatology today, mountain tundra, and after we've done that, we're going to do neckstretching. And if you participate in the neckstretching, then it's better at your own risk. Mountain tundra. Just as there are varying life zones between the equator and the poles, so there are varying zones of life on mountains, each with its typical community of plants and animals. What we're trying to express in a bit complicated way is the higher you come up on the mountain, the colder it gets, basically. You can live on 500 meters, basically completely normal, and still on 1,000 or 1,500 meters, only slight differences. But if you come higher and higher, different trees are growing, different grasses growing, different animals are there. The air gets denser, it's not, I don't know the right word, there's not so much air to breathe. It gets also colder and so on. So the first 1,000 meters doesn't matter much, but when 2, 3, 4,000, and basically from that onward, no one can live from around 4,000. 3,000 is already pretty high. Basically, we're saying there are different climate zones. At the beginning of a mountain, it's almost the same. When from 1,500 meters, there are already different trees, different lakes, different rivers, different stone also because it's a mountain. It's all different, and it changes when every few hundred meters it changes again. Basically, the same as from the equator to the poles. So the equators, for example, in North and South America or in Asia, in Indonesia, it changes when upwards up to Siberia or down also to the Antarctica. Here would be a map. Now, mountain tundra. This is largely because the temperature drops by about 1 to 2 degrees Celsius for every 100 meters. 1.2, it must be 1.2. So 1,000 meters would be 2 degrees. If you know 4 meters up, it are 8 degrees less. That's quite something. So if you're going on a mountain 3,000 meters high, you have 30 times 0.2 degrees, so 6 degrees less. That is already a different climate zone. 6 degrees less. Mount Kenya, near the equator. That is in Africa. Where the Lake Victoria is. See? Near the equator has as great a range of life zones in its 5,200 meters. So it means 5,000 meters high, and it are then every 100 meters 0.2, so it's 2 degrees per 1,000. So 5 times 2. It are 10 degrees colder on the top than on the bottom. To basically. As there are 10 kilometers between it and the poles. So we're saying from Kenya to Antarctica, it's around 10,000 kilometers. And the difference with going from the mountain, from the ground on the mountain, Mount Kenya, I'm not sure if it is in Kenya. I'm not completely sure if Kenya is there. I thought it is a bit more to the line. Okay, so on the Mount Kenya, if you go from the bottom to the top, you make basically a difference as going completely to the pole. I think it's even a bit greater. Okay. The altitude of the different zones varies in different regions. The tree line, for instance, the line above which trees cannot grow, varies from about 3,500 meters on the equator in Africa to about 2,000 meters in the European Alps. So in the Alps in Europe, already at 2,000 meters, trees are scarcely growing. There are a bit higher still fir trees, but trees are getting very rare, and from 2,000 meters on, there are oftentimes no trees anymore. So I'm a bit wondering, it seems a bit little with just 0.2 degrees per 100 meters. It would be just 4 degrees. And the other things don't have that much an influence. Whatever. It is so that there is a tree line, and if you look at the mountains, which are around 4,000 meters high, when around at the half, so around 2,000 meters, there are very scarcely trees growing, and then basically no one anymore, up around 2,500 meters. Now, they are saying in Africa, there at the Mount Kenya, it is by around 3,500 meters. In the Alps and Europe, 2,000. Beyond this line, the vegetation dwindles to tundra, similar in some ways to that of the Arctic. So we haven't read tundra yet, but tundra there would be tundra. That is similar to the Arctic, so there are no trees growing, and maybe you get a bit more information. With mosses and lichens, so there are basically a lot of ground plants, not trees anymore, so mosses and lichens. Lichens, we did it in botanic, that are little plants which work as symbiosis together, so it's a fungus and the, I don't know what it's called, I forgot it, and the other thing with it. So it's basically just a little fungus. But the alpine tundra can also sustain more plants than would survive in the Arctic. The slope of the mountains means that water drains away and does not form a permanent layer of ice as happens on flat land. I was saying the following. The tundra here in the north of Russia, where is it flat? There are no mountains. That means if there's water and there's water, the water just stays there basically almost in the ground, or it stays there. And in the winter, or almost the whole time in the permafrost regions, maybe you're going to get that somewhere also. Basically, the water is standing there and that water then freezes. The Alps or other mountains, they are steep, so the water just runs down. There's never any water standing, so that ice can come. And therefore, there are also other plants growing in other mountains when on flat tundra. So mountain tundra differs from tundra. For example, because there's not ice just standing like a swamp a bit in the ground, but more ice. But the alpine tundra can also sustain more plants than would survive in the Arctic. The slope of the mountains means that water drains away. Everything drains away. And does not form a permanent layer of ice as happens on flatland. There is also more intense solar radiation as soon as the snow melts in early spring. Bulbs burst into flower and herbs bloom during the winter. Okay, the meaning of the solar radiation, now something I misunderstood first. They don't just mean that there is more solar radiation, so that if people go there, they have to be careful, because it's like going to the beach in the summer suddenly. There's very intense sunlight because it's higher up. There's not so much air which the sun filters through. Now the atmosphere of the air is pretty small. We did it in space science. It's 100 kilometers when basically space starts. So let's take even that big height, 100 kilometers. If you go a mountain 5,000 meters high, you have already passed 5% of it. That's pretty little. But that is the space already. There are other types of areas. And there are planes already flying at around 10,000 meters, or satellites or weather things at 50 kilometers. So basically at around 10 kilometers, it is already no air anymore. And around 10 kilometers where aircrafts are. And if you go on a mountain 3,000 meters high, you have passed basically a third of this 10 kilometers where basically nothing is anymore. Basically no atmosphere at all. At 100 is nothing at all. But at 10 there's already no air more. So very much less. If you go now 2, 3, 4,000 meters high, and there's most is at bottom, when you have way less air through which the sun is filtering. The sun comes just and it is filtering basically through the air, and it loses, I don't know how it works, but basically it loses some of its power, and the sun is pretty powerful. It's a burning thing. And now if you go 2, 3,000 meters high, then the sun can go into the skin and does not make it warm. So if you go into the sun, you feel maybe warm, but basically it goes then in with other types of things. In the light of the sun are different things than just the visible light. So there's the visible light in it, that is, I don't know what, white or whatever. But there's also other things in the light which can't be seen. And there's the ultraviolet light in. And that ultraviolet light can go into the skin and damage the cells inside of the humans. So if people go onto a mountain 2,000 or 3,000 meters high, they have way less protection through the air because they have passed it, and they're getting way more harder hit with this type of light from the sun, this ultraviolet light. And that causes then damage to the cells in the skin. That was one thing about the humans. Now the other thing about the plants is, the plants getting more sunlight because they're higher. So as the same thing as humans, and animals probably too, but they have more fur. If humans wear clothes, then it's not a problem. So if humans get higher, and then they're more directly hit with the sunlight, and that can cause over some time damage to the cells. And humans can wear clothes, but now flowers and plants also get more sunlight, and logically they are growing better. That means that in the mountain tundra and mountains, there are more plants growing because as soon as they pop up in the spring, we're getting a lot of sunlight. We're getting very much sunlight. And that is the reason why we have so many flowers. So basically the flowers can grow very strongly because we hit it very strong with the sunlight because we're already so high. Okay, that was mountain tundra. Now I talked so much. Now we don't have time for the presentation. We need the time for the next stretching, and I don't want to rush it through. Maybe I would be able to do it in a minute, but that means that was the climatology part. If you were here for climatology, you can go directly to the next part of climatology, where we're gonna do the mountain tundra again, and then try to do the presentation. If you stay here and participate in the next stretching, then it's better at your own risk. Having the legs standing around shoulder wide apart, and we're breathing in and reaching with the fingertips as far as possible. Again down and reach as far as possible. And again up and reach as far as possible. And out and down. Now reach in front. And again back. And again in front. And back. Now I have the feet standing together, arms to the side, and circle it around. And then the other direction, the bullseye exercise. And now legs, hip width, shoulder width wide apart. Tall up, shoulders back, breathe calm in. And breathe out and slowly turn the head over to one side, only as far as it goes. Breathe again in. And out and bring the chin down onto the clavicle. Breathe again in. Lift the gaze and turn the head over to the other side. Breathe again in. And out, chin down onto the clavicle. Breathe and lift the gaze and turn it again over to the first side. Breathe again in. Breathe halfway out and then circle over to the first side. Breathe again in. And out, circle the head over to the other side. And back into it. Now have the palms together and the elbows and breathe in and reach high. Out and down. In and up again. Out and down. And now the arms back, breathe in. And out and in front. In back. And out. And now have the feet standing together. The hands intertwined behind the back, tall up, shoulders back, breathe in, and out and turn the head over to one side, chin down to the clavicle and pull the hands down to the ground. Breathe in, lift the gaze, turn the head over to the other side, breathe again in, out, chin down to the clavicle and pull the hands down to the ground. Breathe in, lift the gaze and back into the middle. Legs a bit wide apart, intertwine the fingers behind the back, bring them over to one side, tall up, shoulders back, breathe in. Out, head down, head over to one side, chin down onto the clavicle, pull the arm in and the shoulder down. Breathe in, lift the gaze, turn it over to the other side, hands over to the other side, tall up, breathe in. And out, chin down onto the clavicle, pull the arm in and shoulder down. Breathe in, lift the gaze and turn it back into the have the feet standing together, breathe in and lift the arms up. And breathe out and lean back and draw the shoulder blades together. In and up. Out and back. Up. And lean to the side. In and up. Out to the other side. In and up. Intertwine the fingers, reach high, breathe in. Breathe out, reach in front of the back. Up, intertwine the other ear down, breathe in, reach high. Breathe out, reach in front of the back. In and up. Out, lean with long arms back. In and up. Out and back. In and up. Out, hands down. Reach the arms up. Out and down. In and up. bring the hands together and lower down to heart center. That was the next stretching. I thank you very much and until next time.